Okay, so first things first. Let's see if I can turn this a little bit. Okay. We are starting a new chapter. It's chapter 4. We're talking about functions. Welcome to algebra. So far, everything we have done has been something that you've done in pre-algebra. Okay? You've done equations before. We've just done harder equations. We've done order of operations. We just did harder of order of operations. Functions is the start of what algebra truly is. There are two things in algebra that you have to know that carry on to all of the other maths. One is how to solve an equation. If you can solve an equation, then you can solve inequalities and you can do everything else. That's number one. I've really stressed solving equations. Would you agree? We've done a lot of equations. We're going to keep doing a lot of equations. The second is graphing functions. Okay? Because functions don't leave. We're going to be doing functions in geometry, in algebra 2, and if you keep going, we're going to be doing this on and on and on. Okay, so the warm-up is graphing. I kind of talked to you about this. We have an x-axis that goes left and right. We have a y-axis that goes up and down. We always start at what? I've already told you this. The origin. Okay, so A was at 3, 2, x, y. So 3 up 2, yep, not too bad. Obviously, this isn't graph paper. On graph paper, you'd have the lines. A, great job, Liam, except for your circle. B, -2, so we start here, -2 on the x, up 5 on the y, perfect. C, 4, -3, beautiful, who did that one? Is that you? Nope, Isaac, good. And Alec, -3, -4. Guys, are there any questions on how to graph? Graphing is not going to be the first thing that we do, but you need to know how to graph. Questions? Again, I'm sorry, there's a lot of notes. So buckle up, get ready, have a nice clean sheet of paper. I put the date. I've given you a lot of things for equations. I've given you a lot of things for inequalities. I'm telling you that you need to know how to do functions to proceed in algebra. Plain and simple. Everybody with me? Okay. Everybody has this? Okay. So let me take the next step. We've moved at a pretty fast pace. Okay? Like, just because you're with me doesn't mean that we've gone slow. I think the difference between last year and this year is last year you did a lot of stuff online. Is that correct? Like with Mr. Hoover, you guys did a lot of stuff online? No? A little bit? But it was a slow pace, right? Mine is not. It will slow down here. Okay? It will slow down. So we need to talk about a couple words first. The first thing that we're going to talk about is the word relation. Okay? A relation in math. Any set of ordered pairs. And remember, an ordered pair is always x, comma, y. Always x, comma, y. Okay? Still good. No problems, right? Okay. There are special names for the relation, that ordered pair. The first thing we're going to have is the domain. The domain has several different things that need to matter about it. The domain, first, is the x values of a relation. So that means it's all of the x's. Okay? The second thing a domain is the independent variable. The x values are always the independent variables. So if it's like, what are the independents? It's the x values. Okay? Domain is the x values. It's also the independents. Another name for the domains are the input values. Everybody still with me? Have I lost anybody yet? Okay, so if I say the domains are 3, 4, and 5, you can tell me, well, my x values are 3, 4, and 5. You can tell me, hey, these are the independent values, 3, 4, and 5, just by knowing that it's the domain. If I give you x's, so watch this, you ready? You don't have to write this down. What are the domains?
3, 4, 9, 7.
What? Say it again.
9, 7.
9? Well,
Oh wait, 3, 9, 12.
3, 9, and 12. Because this is a relation. It's any set of ordered pairs. There they are. And we know it's always x comma y. My x's, I missed the one there. That's my domain. Does anybody know what the other part is called? And you might have been taught this. You might not have. Starts with an R.
Oh, the radical?
Not quite. It's all right. They are called
Oh, yeah.
the range. And guess what? We're going to have 3 things for the range. What do you think number 1 is going to be for the range? What?
Y values.
Yep, they are the y values of a relation. Okay? You guys are smart kiddos. I know you can do this. If the domain is the independent, what do you think the range is going to be?
Dependent.
Very good, Isaac. Okay. Last but not least, if these were the input values, come on, Kendall, what do you think the y is going to be? If the x's were the inputs, what's the opposite of in? So it's going to be the? Very good. Kendall, are you sleepy? Huh? Yeah. These are the output values. So we have inputs, we have outputs.
I thought the dependent was variables, not values.
Oh, thank you, thank you, thank you, thank you. Okay, now, let me try to wake you up a little bit. So, I went shopping. I know that I talk about lifting and, well, you know, all these sports things. I'm also a huge nerd. Like, you have to understand that. I love fantasy, I love sci-fi, like most of the books that I read, I want to go someplace else. My wife got me some new socks. Just want you to see my nice Harry Potter Gryffindor socks. Show it for the camera. There you go. Kendall, are you laughing at me? What are you laughing at? Kendall, you appear to be laughing at me. Or are you laughing at my socks?
Stop making fun of his new socks.
Yeah, don't make fun of my new. They're awesome. I wore Ravenclaw yesterday to church. It was great. Are you making fun of me? A little bit? You can say yes. The guys aren't laughing at me. It's because they're smart. They know better. I'd throw something at them, like a shoe. They're great. They're great socks. I can't get my shoe back on them. Wait, almost. Okay. So, we have these. Now, let's talk about, are you still laughing at me? Oh my gosh, okay. So, ways to show a relation. 1 is literally to say the set A, 3, 4, 5, 12, -3, 4. Okay, so there's the first thing. You can see it with the ordered pairs. Okay, that's saying set A is that ordered, that set. Right there. This is saying set A is this relation. Another way to show this is with a table. And we would have x, y. 3, 4, 5, 12, negative 3, 4. Now, here's what I need you to know about this. Listen. If we're given a table, could we write ordered pairs? Well, this is 3, 4. We could write the ordered pair. This is 5, 12. We could write the ordered pair. Negative 3, 4, because it's x, y. Everybody still with me? Another way to show this, and I'm going to make a graph, is with a graph. I'm not going to graph 5, 12, but I could have a graph 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I could have this point, this point, this point, this point, okay? So a graph is another way to show a relation. Have I lost anybody yet? Okay. There is one more. May I put it over here? Would that be all right if I put it over here since I'm running out of space? The last way to show it is called mapping. You have 3, 5, negative 3, 4, 12. Now wait a minute, Mr. H. There's a 4, a 12, and another 4. Well, do I need to write another 4? No, because here's how mapping works. This 3 goes to that 4. That ordered pair is 3, 4. Where does the 5 go to? 12. That's saying 5, 12. Where does the negative 3 go?
4.
To the 4. That's saying negative 3, 4. Okay, everybody still with me? Have I lost anybody yet? Okay, I'm going to give you a second, copy it down, make sure you get caught up. You should have all of these examples. Like, again, you want your notes to be pretty clear today. I didn't take attendance. I should probably do that before they call. Ugh. Okay, so looking just at the mapping diagram, what are my domains?
3, 5, negative 3.
What are my ranges?
4 and 12.
That's it. You don't need to say 4, 4, and 12, just 4 and 12. Okay? What are my input values?
Wait. Input.
3, 5, and negative 3.
Very good. Okay? Not appropriate. Okay. Are we good here? May I erase?
Yeah.
So now we're going to get, now that we have that preliminary stuff, now we can get to what is a function. And I'm going to tell you, it's all right if you don't get it right away. Okay? It's all right. So a function. A relation where every domain has only one exact range. And that's not what the book says, but I'm going to make that make sense. Okay? This is a mathematical statement. A relation where every domain has only one exact range. So what would that look like? Let's start with mapping. So here's an example of a function. 3, 4, 5, negative 1, negative 2, negative 3. The 3 only has negative 3 as its range. 4 only has negative 1. 5 only has negative 2. Notice how there's only one arrow coming off of each of my domains to a range.
Wait,
Go ahead.
what? I'm just
Yeah,
confused.
you're gonna be confused for a second. Each domain only has one arrow going. That's what makes it a function. The domains can only have one arrow leaving their number. So this is a function. Because the x's cannot repeat. Listen again. For it to be a function, the x's cannot repeat. So, function, and then I'm going to put a star. To be a function, the x values cannot repeat. They cannot repeat.
Does this have to do with like what we did earlier with like 3, 5, and -3, or just something new?
Yes, it's using this. So let's look at this. 3, 5, and -3. This right here. Would this be a function? Why or why not? So let's go. This isn't a great definition. This is the book's definition. But let's look here. To be a function, the x values cannot repeat. So let's look at the x values. 3, 5, -3. Do they repeat?
No.
No. So is that a function?
Mm-hmm.
Yep, that's a function. So let's do another example. Let's try another mapping.
What about y?
Does it say anything about the y's?
No.
No. Okay. So 1, 2, 3. Is this a function? Why or why not?
No, because.
Wait. To be a function, the x values cannot repeat.
Yeah, it is a function. Because the x's don't repeat. It's 1, 2, 3, but the y.
Oh, I
So
see, I see.
the ordered pairs. Now watch. Let's do this first. What's my ordered pairs? Well, the ordered pairs are 1, 4, 2, 4, 3, 4. That's what that mapping says. Do my x's repeat? No. So this is a function. Still with me? Okay. Let's try this one. Example 3. Is this a function?
No,
Wait.
Why not, Alec?
because it's 1, 2 instead of like.
So let's name the ordered pairs. What are my ordered pairs?
Uh,
1, 3. Go ahead.
Oh.
1, 5.
Yeah.
And 2, 4.
So it's not.
It's not a function because what?
I repeat.
So
Because these ones
What do the arrows
repeat.
mean? How do you know what to do with the arrows? Do you just randomly guess?
So you're not guessing any arrows. It will come with arrows.
Oh, okay.
Okay? Or it will do this, and you'll have to write 1 and 2, and then you'll show those ordered pairs from this. So this is not a function. Now, here's my question. What are the domains, though? What are the domains? So I could say the domains of this are 1, 2. What's the range?
3, 4.
3, 4, and 5. So just because it's not a function, it's still a relation. It's just not a function. So we can have the domains and the ranges. What questions do we have right now? Okay, so here's what you're doing. There is a front and a back to this worksheet. Okay? So I'm going to hand this out first. I'm going to hand it as the front first. You are given mapping diagrams. You're just telling me, is this a function or is it not a function? Let's take a look at number 1. We're going to do number 1 together. Sorry, hold on. Give it a second. Hold on. Sorry, I went too fast. I apologize, y'all. So take a look at number 1, please. Number 1 has 4, 6, and 8, and has 2, 3, and 7. We have an arrow going from 4 to 3. We have something going from 6 to 3. from 6 to 7, and from 8 to 3. Is this a function? Why or why not?
Because the 6 is repeated.
The 6 is repeated. It's going to both 3 and 7. So that is not a function. Everybody good there?
We just put no or
You just
yes?
put no. Yes or no? Okay, flip it over for me.
Okay.
So take a look at these. You're going to write the domains, something like this, 1 and 2, based off of this, because the domains are what values?
X values.
X values. You don't need to repeat the numbers, and the ranges are the Y values. And then you're going to tell me whether it's a function or not. What cannot repeat for it to be a function? The X values. Is anybody confused?
What if there's like the range is only 1? Do we just put 0? Oh,
If the range is only one number, you just put that number.
okay.
Okay? Go ahead and get started, y'all. You are doing the entire thing. Love you.